Hi everyone, my name is Candy Bongwan-Singh, matric number 278829. Today I'm going to talk about Geographic Information System. A GIS is a system designed to capture, store, manipulate, analyze, manage, and present all types of geographical data. The keyword to this technology is geography. This means that some portion of the data is spatial. In other words, the data that is in some way refers to location on the Earth. Coupled with this data is usually tabular data known as attribute data. Attribute data can be generally defined as additional information about each of the spatial features. An example of this would be schools. The actual location of the school is the spatial data. GIS can use as tool in both problem-solving and decision-making processes, as well as for visualization of data in a spatial environment. First, mapping where things are. We can map the spatial location of real-world features and visualize of spatial relationship among them. For example, a map of frac sand mine location and sandstone area in Wisconsin. We can see visual patterns in the data by determining the frac sand mining activity occurs in a region with a specific type of geology. Next is mapping quantities. People map quantities such as where the most and least are to find places that meet their criteria or to see the relationships between places. The third one is mapping density. Sometimes it is more important to map concentration or a quantity normalized by area of total number. Number 4 is finding what is inside. We can use GIS to determine what is happening or what features are located inside a specific area of region. We can determine the characteristic of inside by creating specific criteria to define an area of interest. Next, finding what is nearby. We can find out what is happening within a set distance of a feature or event by mapping what is nearby using geoprocessing tools like buffer. The last one is mapping change. We can map the change in a specific geographic area to anticipate future conditions, decide on a course of action, or to evaluate the result of an action or policy. There are 5 components of GIS. The first one is people. GIS technology is clearly of limited value without people to manage the system and to develop plans for applying it. Users of GIS range from highly qualified technical specialists to planners, forecasters, and market analysts who use GIS to help with their everyday work. Second is method. Methods are well-designed plans and application-specific business rules describing how technology is applied. Third is hardware. The hardware is the computer and peripheral on which the GIS operates. Today, this could be a centralized computer server running the Unix of Windows NT operating system, a desktop PC, or an Apple Macintosh. The computer may operate in isolation or in a network configuration. Next is software. GIS software provides the function and tools users need to store, analyze, and display geographical information. The key software components are GIS software and database software. One of the most important components of GIS is the data. It is absolutely essential that data be accurate. The following are different data types like vector data, raster data, image data, and attribute data. There are 3 major fields for GIS applications. First, use as spatial data in the inter- and intra-departmental workflow. Second, spatial analysis and visualization of issues. Last one is serving the public with information based on specific locations. Next, how does a GIS work? In a GIS, different types of information are represented as separate map layers. Each layer is linked to descriptive information. Layers are combined to make a map. There are 5 steps in the GIS process. First, frame the questions. This step seems straightforward because typically you are assigned a project to obtain specific information. Some projects involve answering several questions derived from a high-level question. Step 2 is explore and prepare data. This step can be the most time-consuming. If you do not have all the data needed for an analysis project, you must collect it. For each data set, explore the feature geography, attributes, and metadata to determine whether the data will be useful for your analysis and what kind of preparation you need to decide what data format to use. Project data does not have to be all in the same format, but it can make things easier. The important thing is to verify that the analysis tool you need to use accepts your data format. Step 3. To choose the appropriate methods and tools for an analysis project, consider the questions framed in Step 1 and document the methods and tools that will answer each one. It is helpful at this step to diagram the analysis. The diagram does not have to be anything fancy. In Step 4, if you have diagrammed the process in Step 3, then in this step, you simply follow the diagram, completing each task in sequence, and the last step you will examine and refine results. Why GIS is unique? GIS is layer-centric. Map projects are built with layers of data. Each of these layers can be stored in a standard relational database management system. In this way, a GIS combines the visual benefit of a map with the power of a database. For example, base map, roads, land cover, environment, weather information, and vehicles location. Next, GIS is more than a map. In a map project, GIS sorts all these different types of data by their common geography. This is what gives GIS its unique analytic ability. Because information is normalized by a specific place on the Earth, you can see relationships between otherwise disparate datasets. For example, geography integrates and organizes all kinds of data, collect data once, then use it often for multiple purposes. There are some benefits of GIS. First, improved decision making. Decisions are made easier because specific and detailed information is presented about one or more locations. Second, reduce cost and increase efficiency, especially regarding maintenance schedules, fleet movement, or scheduling timetables. Third, improve communication between any involved organization or departments as the visual format is easily understood by all. Number 4 is easy record keeping. Geographical changes are easily recorded by GIS. For those responsible of recording the changes. Last, managing geographically, knowing what is and will be occurring in a geography space in order to plan a course of action. To conclude, nowadays GIS got very much scope in almost all the fields, such as mapping to identify the borders of cities, districts, country, etc. It is also helpful in finding the population of the areas, essential to study geological setting of the area by digitizing maps. GIS is only one of tools to make data visualization. WebGIS in the integrated system using automatic data replication or update will give more benefits like reduce manpower, accelerate the routine process, and make standard report format. So that is all from me. Thank you so much.